It's going to tie in very nicely to the lesson that we're going to have this evening. Right. I can't remember if I pointed out that I was crossing out number 3 or if I just did it on my own, but number 3 is gone, so ignore that one. Right. So number 2, and I'll get rid of the star because it's no more important than any other question. We have h of r of x. All right. So, and again, I'm going to do what I did with number 1 and say in words what this really means. All right. So what this is telling us to do is replace all x in h of x with the function r of x. All right, that's what this notation is telling us to do. So if I rewrite my function h of x, so here's h of x. And I write it in such a way that I'm replacing every x with the r of x equation, well, r of x expression anyway. That would be this. We could do the intermediate step by saying we're actually literally replacing x with r of x. And then the follow-on step there would be to say, okay, h of r of x, because these two things are equivalent, h of r of x would then be equivalent to x plus 3 as a quantity squared. All right. Now, the left-hand side, I can make the substitution. I can write this as h of x plus 3 because r of x and x plus 3 are the same thing. I can make that swap, or I can leave it as is just to have the right notation, right? Because the question is telling us to figure out h of r of x, it kind of makes sense to have it in this form. All right, but this would be my composed function. All right, and so we're always looking, whenever we're finding a composition of functions, to replace the variable in one function with the other function. All right. So then the second part tells us to go in the reverse order. It's saying replace all the x's in r of x with h of x.
Professor, I'm a little confused why, like, where the x on the x squared went. The h of x equals x squared. Now I see that you have x plus 3 in parentheses squared, but where's the x?
So the x was replaced with the x plus 3.
So everywhere you see an x, even if it has an exponent, has to be replaced. So you add the exponent always outside of the parentheses?
Right, exactly.
Okay,
because it's an entire expression that's being replaced, or that's doing the replacement. So in the second one, we have, we're replacing all the x's in r of x. So let me write r of x is equal to x plus 3. So if I'm replacing all of the x's in r of x, so that would be this x and this x, I'd rewrite it with open spaces instead of the x, and then I would fill in those open spaces with h of x. All right. And so knowing that h of x is the same as x squared, allows me to replace the h of x with an x squared. And at this point, you could drop the parentheses if you want, because they don't factor into the simplified form in any way. They don't do anything. They don't accomplish anything. But I could also have written this as r of x squared, because again, that's what the h of x is equivalent to. Let me do that in a different color. H of x and x squared are the same thing, so they're interchangeable. That's why we're able to make the substitution here and here. All right. Now, like I said, we could rewrite this. We could write it as r of h of x is equal to, and just rewrite it with x squared plus 3 and call that our final answer. Now, part C is telling us to find h of r of 5. All right. Well, we know what h of r of x is equal to. That's this expression here. H of r of x is equal to x plus 3 squared. Let me get rid of this stuff. So if you do a compare and contrast here between this or these two expressions, you see that the only difference, aside from the crappy handwriting, is that one of them has an x and the other has a 5. Right? So this is saying replace all x's in h of r of x with 5. So I'm going to take my h of r of x. I'm going to swap out the x for a 5. So h of r of 5. So everywhere I have an x, I replace it with a 5 instead. And then we can simplify. 5 plus 3 is 8, squared is 64. All right. Now, computationally, it's definitely a lot easier. What I did on Desmos a week ago, but I've done a lot of things on Desmos, you can see, but I created the composition of functions, Desmos, like I said I would. Right? I took the one that we did in class and I just cleaned it up a lot. The thing is, it's in terms of F and G. So it could be kind of annoying. What you could do, if you want, is change the F and the G. This is all on Blackboard. I have it linked up there. I'll show you in a couple minutes. But you could change your F to an H, change your G to an R. Well, do that everywhere so that it's consistent. All right. And then put in the appropriate H function, which is x squared, and x plus 3 for the R function. All right. Then if you want, you can look at the graph, you can turn all these on. I mean, that's great, it's wonderful, but not necessary, because what we're looking for is h of r of 5. So slide the slider to the value you wish to use to evaluate your composite functions. So I just slide this over to a 5. The issue is I have to change my F's to H's everywhere and my G's to R's everywhere. But if I do that, I'll just get rid of that one so it's not distracting. It'll spit out the answer. You know, and you look at it with all the changes there, it's kind of like more trouble than it's worth. However, if I go back to scratch here, let me see, I'll just open it up again. So blank slate here. and just think of f as h. So type in x squared for the f, knowing that that's really h in the problem. X plus 3, we put that in for g, knowing that that's really r in the problem. When a question says h of r of x, we would interpret it as f of g of x. And slide the slider accordingly, taking note of the appropriate value, which would be 64. Right? So you don't have to change it to h's and r's, because it's very annoying, I would think, especially if you do one question on a test that asks you for, the function in terms of h's and r's, and then the very next one goes back to f's and g's, and you're like, oh, dang it, I just changed everything to h's and r's, just for one problem. Or even worse, it's h's and r's for one problem, then it's m and n for the next one. You're like, oh, I'm gonna change it all to m and n. It's better to think of it all as f and g. So if you want, just go ahead and change the problem. You can't change this part of it, but you can certainly change this to f and g and act accordingly. Right? There's nothing wrong with that. All right. So that's that. Let me stop this recording.